Lab 3 Circuits. Introduction. In this experiment, we utilized an online circuit program to simulate and model circuit behavior. The purpose of this experiment was to compare the calculated current, modeled RC, and modeled potential difference to the actual RC that we calculated and the potential difference of the circuit. The physics concepts used in this experiment were potential difference or voltage difference, resistance, capacitance. We found that the circuit modeled RC very close to, based on graphing throughout time, close to what was the actual circuit RC. And we also found that calculated and simulated current and potential differences are very similar to one another. Quick overview of the results. So in figure 1, we can see how the voltage changes with respect to the negative end of the battery throughout time. So we can see that it increases and decreases. And figure 2 shows the relationship between the natural log of voltage difference, and the equation represented will be shown in the next image. So experiment theories and model assumptions. So we have our three equations here: voltage difference using this equation, capacitance, and resistance. One of the assumptions in this experiment was that the resistance of the wire, the ammeter, and the voltmeter were all negligible. Sources of error might have came from the not letting the capacitor fully discharge or charge completely. Experiment methods. Various situations were modeled throughout this website. First, we compared our measured current to what we should have calculated based on the different initial values. Then we calculated the round trip voltage by comparing the voltage difference between different points on the circuit and summing them up and measuring that to a theoretical based on what we know of closed circuits. Finally, we calculated RC from taking time measurements, looking at voltage throughout time for 20 seconds, and using the equation of this graph to calculate the RC. So we found the initial values, the initial resistances for the resistors in the first part were 47 and 100 ohms, and the initial voltage of each battery, so there's two batteries, was 1.5 volts each, so 3 volts total. In the RC circuit, the voltage of the battery was then changed to 9 volts. For the actual graphing part of the experiment, the resistance of the bulb was 30 ohms and the capacitance of the capacitor was 0.2 farads. The system is a circuit and the surroundings, there's nothing in the surroundings. Discussion. The calculated current, just from numbers, was 0.02048 amps, but the observed I from the ammeters was 0.02 amps. The expected round trip delta V theoretically should be 0 volts, and we observed after summing all the different delta V's to be 0 volts. The calculated resistance using current was 47 of the 47 ohm resistor was 48 ohms, and the calculated resistance of the 100 ohm resistor was 102 ohms. We found the resistance of the wire and the ammeter to be 0 ohms. The 10 ohm bulb. So we found it took 6.2 seconds to charge and 12.4 seconds to discharge, while for the 20 ohm bulb, it took 12.7 seconds to charge and 20.2 seconds to discharge. The RC from the circuit, using simply found from the circuit, is 6 seconds, but the RC calculated from the observational points was 6.06 seconds. Discussion. What if a real ammeter was used, it most likely would have some resistance to it, ultimately affecting the current of the circuit, making the current probably a little bit less. What if, without a resistor and using a real battery, the capacitor would end up charging and discharging faster, as larger resistance makes current move slower as time progresses? Conclusions. RC of the circuit accurately represented by graphing voltage throughout time and finding the measurement this way. And as a whole, the online circuit was a very effective model of what may occur in reality or theoretically.